Please welcome to the stage Chief Corporate Architect, Oracle, Edward Screven.
Hi, how you doing? Actually, I don't have the clicker. There we go. Got it. Problem solved. All right. Okay, today I'm going to talk a little about our cloud platform strategy, but I think it's not really possible to begin discussing that unless we talk also about Fusion, right? And the reason is that when we built Fusion applications, we made a few important rules. And one of the very important rules was that we were only going to use technologies to build and deliver Fusion applications that we also made available to our customers. And the reason is, number one, we wanted to take what we knew had to be true about those tools and those runtime environments and those deployment vehicles. We wanted that what we knew had to be true for our Fusion SaaS applications would also be useful for our customers who want to build their own applications, right? Now, when Fusion applications, of course, is a very broad suite of functionality, right? HR, sales, ERP, a very broad suite of functionality, and that's really the history of packaged applications. It's not just a cloud phenomenon. It's always been true, right? If you look at the history of packaged applications, they started off with point solutions, a sales thing, a financials thing, an HR thing, and over time, vendors like Oracle, we built out full suites of that functionality, and that was important because it meant that customers had a single data model, they could use a single set of tools to extend, they could do things like have a single set of administrators to administer the whole thing. But the thing is, no matter how complete we make those suites, no matter how complete they are in the cloud, right, customers still want to be able to extend them. Customers have their own business processes that are unique to their business. They have other applications they want to integrate with that we don't implement. They have a lot of bespoke applications that they want to integrate with. Now, when I say extend those applications, I don't always mean, hey, they want to write a bunch of code. Sometimes what they really want to do is they just want to customize the behavior of the application for their users. That doesn't mean, like it did in the old days, writing and changing the code of the underlying applications. For eBusiness Suite, for other on-premise things like SAP, what do customers do? They go and they edit the code. Well, that's a bad idea because it means it's very, very hard to upgrade. So for Fusion applications in our cloud, instead what we have is we have well-defined interfaces for integration technologies that our customers can use to modify their behavior and customize their behavior for their own use. So changing workflows between components of our applications, using those event points that are defined as part of our applications to invoke their own business processes and code that they write themselves. Now, when they do that, we need to make sure that you, our customers, can use exactly the same UI technologies that we do. That you can do things like have modern web interfaces, mobile, make sure that you can do something like have voice interfaces and chat interfaces. And of course, you also need to have applications with rich content. I mean, I think, to me personally, I think one of the biggest changes I've seen in SaaS applications, and one of the biggest changes I've seen in what our customers want to do is, they want to integrate a much richer set of media. They want the experience of using the application to be a lot more immersive. Now, today I'm going to talk about a few of those technologies that we use to build our applications and we make available to you. So I guess we'll just jump to the first one. Integration Cloud Service it's an Oracle Cloud Service that lets you define flows of information between applications that are either running in your own cloud, running on-premise, that either we wrote or you wrote or some third party wrote. Right? It has a large library of pre-existing integrations, more than 75. It lets you connect your SaaS applications with on-premise apps. And it also is AI powered. And by that, what I mean is you can describe data transformations that you want to have happen. You can build custom flows of that information. Those custom flows of the information, by the way, it's not just between pieces of programs all the time. It could be between pieces of programs and users. But one of the things that we can do, and I'm personally very excited about this, is that we can actually watch those flows, and we can learn from those flows. We can infer workflow rules so that we can make the flows of information be more efficient and effective over time. Now, actually, that's fine. One customer who's using Oracle Integration Cloud very successfully is called the Co-op. They actually are a UK-based cooperative. They have 2,600 retail locations. Most of them are groceries. Now, if you know something about the grocery business, you realize, or actually pretty much any retail business, you know that hiring is a constant activity, right? You get a lot of turnover in retail locations. And so what the Co-op did is they used Integration Cloud to integrate HCM, our cloud HCM, with some of their own custom behavior, some of their own custom rules. And they use that to speed up their hiring by a factor of 4. And if you have to hire as many people as they do all the time to keep those 2,600 retail locations populated, that's a big deal. And I think even more importantly, because they have a better hiring process, they have a better retention rate. So their retention rate on their employees went up by 11%. Now, when you're running an Oracle Cloud, of course, you have to be secure. When you're running on-premise, you have to be secure. And that's why we provide a complete set of identity products. When you run an Oracle Cloud, you can use Identity Cloud Service. When you run on-premise, you can use IDM. That rich content that I talked about earlier, it comes from what we call Content and Experience Cloud. It lets you manage content, all kinds of rich content, in one central hub. It lets you deliver that through multiple channels, and it lets you manage the authoring and creation through workflow. One customer that uses Content Experience Cloud is a company called Solaris. Solaris is a private jet operator. And what they do is they use Content Experience Cloud to inform their customers about the status of their jets. What's the availability? What's the maintenance status? They integrate that Content Experience Cloud using Integration Cloud Service with Fusion ERP and with Identity Cloud Service. Of course, you want to be able to build UIs. I mean, if you go out and you build an extension to our applications, very often, of course, you've got some custom user interface. Or sometimes you're building a completely new application, not related to Fusion applications at all. And you want to do that productively. And what we make available to you is Visual Builder Cloud Service. Our own developers use Visual Builder Cloud Service to build our SaaS applications. So it lets you rapidly create mobile and web applications. You can use the Fusion data. You can access the Fusion data. You can access your own data. You can actually also make just REST calls. So I think a very popular common use of Visual Builder today is building UIs that interact with microservices through RESTful interfaces. All of our new Fusion application modules are built with Visual Builder. Panasonic uses Visual Builder. What they did is they took, they're a Sales Cloud customer. But what they did is they went out and they built a custom partner portal. So someplace that their partners can come in and register deals. Okay, when they built a new portal using Visual Builder, it took them 4 months. 4 months. After 4 months of work, deal registrations went up by 21%. So by having a better interface with their partners, they're making more money. Now, web is great. Mobile is great. But if you think about the way that users on the go need to and want to interact with their users, I think many times they want it to be conversational. They want to be able to have chatbots. They want to be able to have voice. If I'm standing up a customer service portal for an average consumer, right, learning to navigate through a bunch of web pages, that's probably not something that they want to do in the moment when they've got an issue. If they can converse intelligently with the system, they're going to have a much better experience. If they have a better experience, then that customer is going to be a retained customer as opposed to someone who's not happy. So one example of a customer, an Oracle customer who's used Oracle Digital Assistant is a company called Hermes in the UK. Now, they are a logistics provider. In fact, they're, I believe, the most important, the largest distribution partner for Amazon in Europe. Now, what Hermes did is they replaced their existing customer service portal with a chatbot using Oracle Digital Assistant. And the number of issues that escalated to a human operator, a human being, went down by 40%. Went down by 40%. So you think about that. A customer was satisfied enough with a chatbot that they didn't feel like they needed to talk to a person. All right. So when you're building these integrations, or you're building just brand new applications, at a certain point, you need to code. Now, personally, I'm a programmer. I want to get to that stage right away. Okay. Now, if you look at what's out there, the way that people build applications today, the way that people have built applications in the past, there's definitely some change. I mean, traditionally, for Java, people built servers using J2E, using Jakarta EE, using a traditional kind of application server. Today, people are using some other techniques. They're using microservices. They're using microservices built in other languages: Python, Node.js, C++, Ruby, R, what have you. I'm sure there'll be another one. Okay. Now, what we do at Oracle is we make sure that we can support that entire broad range of styles, using traditional containers like J2E, using lightweight containers from microservices like Helidon, we'll talk about in a bit, making sure that you can interact with microservices implemented in other programming languages. Our goal is to be flexible. Our goal is to give you choice. We continue to invest in J2E. We continue to invest in the ways that you may already have built your applications. Many customers continue to build new applications in J2E, and we're very happy to support that. We want to make sure that you have the same choices available on-premise as you do in the cloud. Build and maintain your J2E applications. Build and maintain new microservices-based applications in whatever programming language makes the most sense for you. So what does it mean to have a modern application? I mean, you kind of hear these terms thrown around a lot. You hear things like cloud native. What does it really mean? Well, it means different things to different people, frankly. I think there are a few key things that are pretty universal, though. One is the development methodology is different. So you hear about DevOps. Well, DevOps means instead of the more traditional approach where I've got this group of developers, totally different group of people who do installation and management, right? And they talk occasionally. It's one group. You have the same resources, or at least resources who are very close together in the organization and talk to each other quite a bit, building the code, operating the code, maintaining the code. That's how we do things at Oracle now. I mean, as we transitioned into becoming a cloud company, we deliver cloud services through DevOps. Microservices. Microservices means, hey, don't build one giant monolithic Java program, right? Build separate, smaller programs, some in Java, some in not, that interact with each other over network protocols, usually queuing so you get better availability. And of course, containers. Containers let you deploy quickly and easily, both in the cloud and on-premise. Now you notice, nothing I said there meant you can't use J2EE. And so one thing that's very important to us is make sure that our customers can continue to use J2EE, but use it in a new modern application development style. That's why we give you tools to move WebLogic configurations to containers, Kubernetes. We let you create images. We let you patch the images. We let you manage Kubernetes resources for WebLogic. You can export WebLogic runtime metrics to Prometheus and graph those metrics with Grafana. Now we're going to be releasing WebLogic Application Server 14.1.1 sometime this calendar year. And it's going to include the latest J2E 8 and JDK, and it will support both JDK 8 and JDK 11. Now I'd like to invite onto stage Antonio Nappi. Okay, so Antonio works for an organization called CERN, and if you don't know, CERN is just the premier high-energy physics research laboratory in the world. We're not going to actually talk about high-energy physics. We are going to talk about WebLogic. And so you guys use WebLogic today.
Yes, exactly.
What do you use it for?
Basically, we run a WebLogic service that hosts Java critical application that I use in different scope for the CERN life. Our users are mostly developers in different areas, engineering, administration, IT. And we host around 400 WebLogic cluster across different environments, development, testing, pre-production, production.
So you said 400
Yes,
WebLogic
almost 400 WebLogic clusters.
400, okay. All right, so what are some of the challenges? Because if you have 400, I'm sure there must be some. What are some of the challenges that you have managing all of those applications across all of those clusters, and how do you address them?
Yes, I mean, it was almost 10 years that we are running WebLogic at CERN, and we did not have really big issues, any big problem. The only thing is that we were spending a lot of time updating, patching it, and spending time in the maintenance task. So at some point, we could not really focus on developer needs. We could improve our services with the new features. So we decided to look for a solution that could help us to improve the way that we were deploying WebLogic, so in a faster and easier way. That's why we started to have a look 2 years ago to Kubernetes. And now we are in the process of migration. So our production is moving to Kubernetes. And we are extremely happy because we saw really the difference also in terms of how much we can speed up a new environment for our users.
So you mentioned Kubernetes. Are there other tools that are important to you?
We use OpenStack, Terraform to deploy Kubernetes clusters. We use ILK, the Elastic Stack for loggings, the TIG stack, so basically Telegraph, Influx, Grafana for metrics, but we are moving to Prometheus. And to finish, we use a mix of custom tools and open source tools provided by Oracle for WebLogic. In particular, we are using the WebLogic deploying tooling. Basically, it allows us to easily configure WebLogic. In fact, our pod, when they start, they run the script to create the domain in a few seconds. And also, we are now evaluating different tools that could help us to improve our system. The WebLogic the image tool that basically will help us to make our images, Docker images, faster and easier. And also, and probably, the latest version was fitting our requirements. So we are going to use soon in the next month. And also, we want to have a look to WebLogic exported. As I said, we are moving to Prometheus. This is the natural solution for the metrics.
So what's next for you guys? Are you going to grow your usage? What are you going to do next?
Next, one of the advantages of Kubernetes is the fact that our infrastructure become much more portable. So it means that now we can run our service everywhere, on-premise, on the cloud. So the idea is to evaluate the Oracle Cloud Infrastructure and the Oracle Container Engine for Kubernetes for our disaster recovery plan. In fact, I will have a talk in 1 hour, so you should join.
OK, all right. Hey, thank you so much for joining us.
Thank you for inviting me.
Thank you. So Antonio told us how they're using WebLogic Server to deliver so many critical and important applications. As I said before, of course, you can certainly use, and we're doing a lot to help our customers use WebLogic in a cloud-native fashion, to use it for a modern development experience. Now, sometimes, though, you want to build Java-based microservices, and you'd prefer not to have the traditional heft of WebLogic, the traditional heft of a J2E server. And so the way that we're doing that is with Helidon. So Helidon is a project that is a lightweight framework for Java microservices. So you can deploy those microservices without an application server, right? So it's standards-based. It uses open source Java libraries. It is itself an open source project. Now, it's not an either-or situation, right? You don't have to choose WebLogic J2EE or choose Helidon. You can easily build mixed environments, because taking a step back, what you're doing is you're building a collection of cooperating services. Some of those services can be J2EE based. Some of them can be based on Helidon, right? You can mix and match those things. Of course, you're going to use containers. You're going to use containers to deploy everything, right? And you're going to use Prometheus for monitoring and Grafana for reporting, right? But you can have code running in both your traditional J2EE installation and Helidon microservices. Now, if you do that, you got to think about management. Now, Antonio is a very smart guy, and he put together a bunch of tools, right, to help him manage what is, of course, a very complicated environment, right? All of those 400 clusters. So what we're doing at Oracle to help everyone else, and maybe Antonio will take a look, is we have something called Project Tiburon. So Project Tiburon is a way to manage application development and deployment, managing containers. Those containers can run microservices, and it's a collection of exactly the same kind of tools that he just mentioned. Prometheus, Elasticsearch, Grafana, JournalBeats, all that stuff. Okay, so you will get, as WebLogic customers, support from Oracle for running a curated collection of those services to help you manage your potentially complex environments of WebLogic and Helidon. Now, exactly as Antonio was saying, the thing about Kubernetes is it gives you portability. You can run those applications you build either on your premise or in Oracle Cloud or someone else's cloud. And you can use Project Tiburon to manage across those environments. You can have clusters in both environments talking to each other, managed by Tiburon. And that's certainly something I think that most large customers are going to want to do. They're going to be hybrid. They're going to have some applications on-premise. They're going to have some applications running in cloud, hopefully Oracle Cloud. Now, developers, of course, use programming languages other than Java. Now, I personally love Java. I've written a lot of Java code. I plan to keep writing a lot of Java code. But sometimes, I admit, I write JavaScript. Sometimes, I admit, I write Python. Probably a lot of you do, too. Now, we want our customers to have the same excellent performance that they get with Java for those other programming languages. And the way that we're delivering that, it was something called Graal VM. Graal VM is a polyglot environment. It can run code from multiple programming languages in the same process if you want. It gives you high performance, multi-language, compilation, and runtime. It has a quite distinctive feature for compared to some other execution environments, native compilation. So you can take an existing JavaScript program or Java program or Python and spit out an executable image. That, of course, has tremendous advantages in terms of startup, which matters a lot in certain kinds of usage, microservices, for example. Now, I've put a chart up here on the screen. On the left, you see startup times for various lightweight Java containers. So you can see that Helidon does pretty well. Right? So Helidon SE, that red bar on the left, lower is better, means faster startup. Right? It looks like it starts up in about 0.9 seconds. Okay? The other ones are a little slower. Okay? On the right is a graph showing startup time for Helidon SE running with Graal VM native image. Now, if you're looking at this on video, maybe that right side looks like we forgot the bar. Okay? But if you see it in a large enough screen, you can see there's a tiny little red thing at the bottom. All right, so let's zoom in a little bit. What we see when we zoom in is, OK, Graal VM native running Helidon SE starts up in 26 milliseconds. 26 milliseconds versus 0.9 seconds. Okay? That's obviously, besides it's much, much faster, it means that the set of problems you can choose to solve with Java or JavaScript or some other dynamic programming language is much wider. Now, I can tell you that matters a lot to us, as a cloud vendor, because we build most of the management infrastructure for our cloud, you don't see, you don't use it. We use it to run our cloud. We build almost all of that in Java. And so by using GraalVM, we get much better performance, much better startup time, much less memory consumption, much more predictable garbage collection times. All very, very important. And so I'd like to invite Chris Thallinger onto the stage to discuss a little bit about GraalVM. Hey, Chris. Okay. So Chris is a very modest title, software engineer at Twitter. So
it's true.
He is a software engineer. He's not an ordinary kind of software engineer. Okay. So Chris, I understand you guys use GraalVM at Twitter. So when did you start using it, and why did you start using it?
So we started using GraalVM compiler specifically in 2016. I joined Twitter in 2016, and I brought the idea over that we should start trying to run Twitter microservices on the Graal compiler. And at my time at Oracle, I already knew that the compiler can give you performance improvements, and so I just wanted to see how that turns out.
Okay, and what's the experience so far?
So the experience is, number one, performance-wise, we see a huge improvement. So I can give you one or two numbers. So the tweet service, everyone probably can imagine what the tweet service is. It's a service that reads and writes tweets. We run that one on GraalVM compiler, and we reduce CPU utilization by 10%, by just switching over to the compiler. And at the same time, reducing P99 latencies by 20%. So this is multiplied by thousands and thousands of instances of that service. It's a lot of money that we're saving. And in terms of stability, we found a few bugs when we started running it. About 4 or 5 bugs or something, but in the last 2.5 years, we had a single issue, nothing. And if you have seen a tweet in the last 2.5 years, we run the tweet service plus a bunch of other services 100% on Graal in production. So all the tweets you've seen in the past were served to you by code compiled by Graal.
Excellent, thank you. And so how extensively is Graal used today, and how has it changed over time?
So right now, we handpicked select microservices. We picked the ones that are the biggest ones in terms of instance size, because then we get the most savings and it's easier to move them over. I would say out of our hundreds and hundreds of microservices, we have maybe between 30 and 40. But instance size-wise, it's way more than that, percentage-wise. We're working currently on a small project where we do a gradual, incremental, automatic rollout to all the remaining services of Twitter.
And so how does Twitter management feel about the decision to use GraalVM?
Well, in the beginning, it was difficult, right? Because I came into the company, I was a new employee, and I said, hey, you want to try this new compiler? And everyone was a little hesitant. But once they saw what the improvements were, everyone was excited, obviously, because who doesn't like to save money?
Okay, all right. So before I say goodbye to you, one thing I want to do is, first I want to thank you for coming here today, but I want to thank you for something else, right? Whenever you build an exciting new technology like Graal, it's not like you can build it and then you can produce it, out to the world in full form, mature, ready to use, right? It always takes early adopters who work with us, right, and help us develop the technology, help us get experience with technology, help us make it better for the broader class of users. And you personally and Twitter as a company have definitely helped us do that. So thank you very much.
Well, thank you.
Now we talked, at least I've mentioned a few times now, the importance to Oracle of making sure that you can run your applications both on-premise and in our cloud. Now, one of the ways that we're able to do that, right, is that we use Oracle Linux. Now, if you attended Larry's keynote yesterday or read some of the news, we announced Oracle Autonomous Linux. So Oracle Autonomous Linux is Oracle Linux running in Oracle Cloud that automatically patches itself, automatically tunes itself, automatically deploys itself. So those are very important characteristics of Oracle Autonomous Linux. But there's some other things that are important about Oracle Linux. One of the important ways that we help people be able to build cloud-native applications are through the cloud-native environments that we make available as part of Oracle Linux. So you can get support from Oracle for containers that include these fundamental cloud-native capabilities. So doing things like Grafana, doing things like Docker runtime, doing things like using Jenkins for continuous integration and build. Right? You don't have to put together all those tools yourself. You don't have to start from scratch. That's a pretty intimidating thing to have to do. Figure out some big collection of packages to start to basically bind to and start downloading and installing and maintaining over time and keeping track of all the security issues that may occur, so I have to patch again. Instead, you can just use the cloud-native environments that we give you as part of Oracle Linux. Now, another important part that you get from Oracle Linux is something we call the Oracle Linux Software Collections Library. So there are these tools out there, other programming languages, other frameworks that are not part of that cloud-native environment, right, that are still very useful for you. So instead of going to lots of different third-party places, instead of trying to pull directly from GitHub or whatever it is that you may otherwise have to do, you can subscribe to a channel, an RPM channel from Oracle, and access those things from us. So they're curated by us. They're packages that are signed by us, right? You can make sure that you're using consistent versions of packages that you need to use. And so if you put all of those things together, you can build your own on-premise cloud-native environment. You can put your applications in Kubernetes. You can run and manage those environments using Tiburon. And by the way, you're going to get excellent performance if you choose to use GrawVM. So back to what I said at the beginning. We're very interested, we view it as our goal, to make sure our customers have choice and they have flexibility. That you have choice in development environment, traditional J2E, microservices. Choice in programming language, Java, Ruby, JavaScript, whatever makes the most sense for you given the problem you're trying to solve. You can run it in your own data center. You can run it in our cloud. We want to make sure you have flexibility, right? Flexibility to make the choices that you need to make in terms of your application architecture. And as it makes sense for you, over time, move to cloud-native infrastructure, move to cloud-native architecture. Thank you very much.